as we have discussed that I will have a unbalanced system. We can have an unbalanced system like this one. I can write down this is VA, and then I can have a voltage here VV, and this one might be VC or different value of VC. Then I can decompose this one into three balance system that we'll have. The first balance system I will have is positive sequence, and that will be given by this is called the symmetrical component. Okay, so we need to understand, we need to know symmetrical component. Okay, symmetrical component, and we have three symmetrical component. One is called the positive sequence component. Sequence. So symmetrical means it is balanced component. So from the unbalanced, unsymmetrical, we are producing symmetrical component. Positive sequence component, and this is given by, so any component, it can be voltage, it can be current. We can write down the voltage or the current symbol, and then we will write down which line it belongs or which phase it belongs. So if it is a phasor quantity, then usually we write down A theta is the phasor quantity. And then if it is a line, then I can just write A, and or if it is the voltage, or we can write down also phasor quantity as VAN, that means line to neutral. And then the number here 1 signifies, this 1 indicates, we can write here 1 or here 1. This 1 indicates this is belongs to, this component belongs to positive sequence. So this is a standard representation. We need to remember this is a standard representation, positive sequence. Okay. Then if it is a negative sequence, component, it will be VA2. So these two, whenever we will find out A2, that will indicate that it belongs to negative sequence component. So these two indicates this negative sequence, and that means 0 sequence component will be VA0. Okay. So this is the first thing we have to identify, that if I have 1 written with my phase, that means it is a positive sequence component. If I have 2, negative sequence component. If I have 0, that means 0 sequence component. That means whenever I have A1, then this is belongs to positive sequence. That means then I will have B1, that should be 120 degree, negative 120 degree. And this length of all the vector will be the same. And then BC1 should be 120 degree apart. Now if I have this one, I will decompose. That means I will have, so this addition This addition, we'll talk about this one. This addition is a vector addition because we are considering AC balanced or unbalanced. All the time we are considering the vector. I think I have discussed in the last class that AC and DC representation is slightly different. If you remember, DC we are representing only with the magnitude. If you say 20-volt DC, you don't need any other information. It tells everything that this voltage is 20 and all the time it remains 20. But for AC, you have to mention three quantities, three characteristics to tell proper description of an AC. And what are these three? Magnitude, that means peak value, then frequency and the phase angle. So if you change any of these three, that signal will be different from the other. If you change the frequency, your signal, two different frequency signal, if magnitude and phase are same, they are not the same signal. But in power system, we are lucky we are using same frequency. So frequency we are not considering. We have to only consider the magnitude and the angle. Okay, that angle belongs to the phase. So that what we are doing. That means whenever you have a quantity, have two characteristics involved, you cannot add them with the normal addition. You have to do a vector addition or phasor addition. So then we have one quantity is positive sequence. Then we have the negative sequence. So negative sequence is nothing but the magnitude will be different. They will be identified as -2, 2, but also the angle, the sequence of this phase will be changed. So it was previously, this was B, now this one will become C, and that will be 2, and this one will become now A. That's why it is called the negative sequence. So this is B, 2. 2 indicates negative sequence. So the phase that is rotating in your, so in your system in three phase, it is continuously rotating these phases. So your magnetic field is created that is rotating, and that rotation you can find out in this way, the positive sequence. So positive direction, in the clockwise direction, you will find out VA1, B1, and C1. Now, if you go negative sequence, you will find out ABC in opposite direction. That's why it is called the negative sequence. It is just opposite way you can find out the phase sequence. So phase sequence A, B, C, you can find ABC, but you have to rotate in opposite direction. That means whenever you have a fault, this particular sequence, this particular magnetic field is produced in opposite direction. And you have to add them another quantity. So I will just add here, that is the zero sequence. So this is VA0 and this is VB0 and this is BC0, and this can be considered as a DC component. So I have two AC component and one DC component that will combinedly produced the unbalanced system. Okay, so just think, I will just turn on the light and then come back. We will continue our discussion. Okay, so we will continue our discussion. And if you have any question up to this, any question? You might have some question later on. So if you have in the next class, you can ask. So now we will come to the representation, how I can represent, then we can do some analysis. Now, for the positive sequence component. So for the positive components, positive sequence component. So what we have? We have VA, and I can consider this angle is 0 degree. Then we have BB, so I will write down 1. So this indicates, so I have BB will be the same magnitude, BB, and this one is making an angle of minus 120 degree. And then we have BC, and that is making an angle of positive 120 degree or negative 240 degree. Now this is the graphical representation. So forgive me, all the lines are not equal, but it should be equal, okay? So this is the balance system. We have decomposed from the unbalanced system. Now, whenever we do the mathematics, we cannot draw all these phasor every time. For our understanding, this drawing is fine. But doing the mathematics, we have to represent mathematically. We have to have some symbol that tells that this is a positive sequence. This is how I will represent 3 components. So if I represent this one, this phasor is represented by 120, right? So we can represent this one. Instead of 120, we can use a symbol. So if you remember that we write down our impedance symbol as X plus I, or let us write down, this is
or J.
R plus, this is R plus, so R is the resistance, and J X L or XC. That is how we are writing our impedance, right? And impedance is a vector, and that can also be written as Z is making an angle of theta. So that's what we can write down, right?
Yeah. Rectangular or
remember?
polar.
So what this I indicates? What this I?
Complex notation, isn't it?
Is it complex notation? But what does it mean?
Imaginary.
Imaginary. And if I draw this imaginary, it will be in the XL will be somewhere here, right? This is my y-axis is considered as imaginary axis, and this is my R. Do you know why XL is always in this direction? Why we consider that y has imaginary axis? This is actually representing, we have discussed with the power system, somebody, whoever attended the power system, this is coming from the vector representation. So whenever we are considering the positive vector, let's say this is my positive vector A, and we usually draw this one in the x-axis from 0 to the axis, to the direction of the positive x part, right? Now, if I tell you draw negative A, so how you will draw negative A? I will tell this one is my negative.
That way.
It will be the same value,
yes,
but in this direction. And if I tell you represent this one mathematically, then I will write A will have a magnitude A and making an angle of 0 degree, right?
Yeah.
So that is my positive A.
Yeah.
My negative A, how can I represent this one? This negative A? That means I have rotated this one in this direction. So if I starting from here, I can go some angle here, then here, then here, then it becomes how many angle I have passed? It's 180 degree, right?
Yeah.
So that is A making an angle of 180 positive, right? So that is actually my negative vector, right?
Yeah.
Now, this negative vector, I can consider this one is multiplied with -1. So this negative vector that we have written here, this is actually multiplied by -1, right?
Yeah.
So this is same as this one. So I can write down this one. Now this one I can also write down. We know that square root of square root of -1 is equal to I, right? Square root of that imaginary definition of I is square root of -1. So let me just clarify this one. So this is square root of -1 is defined as I, right? Right? Got it? So then if I multiply square root of -1 times square root of -1, that will give me I times I, right? And that will give me I times I is equal to -1. So here you have multiplied with -1 that I can represent a vector. If you multiply it with quantity I and again with I, that is actually giving you A with 180-degree phase shift. Now, if you multiply I times I, that will give you 180-degree, then I can find out I is actually 90-degree. That's why we are actually representing this one imaginary part in the y-axis. Because whenever you are multiplying a quantity with I, that is actually shifting your quantity by 90-degree. And if you multiply it with 2I, 2 times I, then it is shifting 180-degree. So that's why we are representing the imaginary in the y-axis.
Isn't it something to do? You can't have a negative square mathematically. It's a convention to allow you to do that.
It's the convention, but this is the logic why we are doing that.
Yeah.
Yeah. So this is the logic.
Because pure mathematically, you can't have a negative square.
Yeah.
You use a system like that to allow you to do that. I mean, it's
okay. So this is now we have done this multiplication. Whenever we have done this multiplication, this actually tells that this quantity has been shifted by 90-degree. So similarly, I can write down that BA, that is making an angle of 0-degree. Now BB, I can tell this is actually VA because this vector is having the same value and that is making an angle of -120-degree. Or I can write down this 120-degree is equal to 240-degree. Now this I can represent this one because is here 90-degree I have represented with I, 120-degree I can represent with alpha. So if I multiply alpha times alpha VA, that will give me BV. Do you get the idea? So whenever I have multiplied a quantity, let's say I am writing this one 9I. What do I mean by 9I? That means if I have a reference here, this is my reference. My 9I is the magnitude of I, and it is making an angle of 90-degree. So this 9I is actually represent 9 as an angle of 90-degree, right?
okay.
Yeah, so this is a vector representation, and that vector, this one 9 is making with the reference, it is making an angle of 90-degree. So whenever you are multiplying with I with any quantity is always indicating that this quantity with the reference, it is making an angle of 90-degree. Now, if I have minus 9i, that will be the same reference, and I have to go in the negative direction of minus 90 degree. So this is my minus 90 degree. Okay. Now, similarly, similar concept we are using here. So we have a quantity VA is equal to VA angle of 0 degree, and VB is the VB angle of minus 120 degree. And for balance system, VA is equal to VB, magnitude is same, the angle is different. So I can write down VB, instead of VB, I can write down VA, and I can just write down this one as minus minus 120, I can write down 240. Okay. And then I can consider that VA is multiplying, I can consider alpha is equal to 1 times 120. Okay. So I can consider alpha is a definition similar to I, but this one is 120 degree phase shift. So in that case, what we can do, if I multiply alpha times alpha, so that will give me 120 times 120. So how to multiply? If I have alpha equal to 120, this is a polar representation, right? So how to multiply? So if I have a vector A equal to magnitude of A, making an angle of theta 1, and B is angle of B, magnitude of B, making an angle of theta 2. Now I want to multiply A, B. So what would be the multiplication? This is called the polar representation, right? So those who has done the power engineering, how will do that multiplication?
1 multiplied by 1 and add the angles, which will be
it will be the general equation is AB, very good. So this one would be theta 1 plus theta 2. So similarly, this magnitude I have to multiply, that will give me 1. And this addition I will have add 120 plus 120, that will give me 1, an angle of 240. So here, this angle of 240, I can multiply alpha times alpha, and that will be alpha square VA. Similarly, can you find out VC? What would be the VC? So this one is positive sequence. We are considering positive sequence because this is minus 120 degree. So VC1, what would be the representation? So VC1 would be equal to VC, making an angle of positive 120. So instead of VC, I can write down VA because VA equal to VB equal to VC. Why I'm writing this one? Why I can write this one? That they are equal.
because
Balance system, because we have decomposed three balance systems. So this is, so I will write this one is, because this one is, or I can write this is V1, V2, and VC1. So this is the balanced positive sequence. So positive sequence is always balanced. So we have considered this is a, because we have decomposed three balance system. One is positive balance system, negative sequence balance system, and zero sequence. So that's why it is coming. So this is VA1. So this is A1. So A1, we will consider all are the same value. So we will have this one will be multiplied. This will given by alpha. So I will multiply with alpha. Okay. All right. So similarly, we can find out, say, negative sequence. Negative sequence. So negative sequence, we have BA2 is making an angle of 0 degree. Then this one is changed to VC2, right? And this is making minus 120 degree. And this one is B2, right? This is making an angle of 120 degree. So similarly, I can write down VA2 is equal to VA2, the magnitude, and that making an angle of 0 degree. So VB2, now VB2 is making an angle, so I can write down VB2 is making an angle of 120 degree. So this one, first we can replace VA2 is equal to VB2 equal to VC2 because it is balanced. Now this angle will be represented alpha, that is 120. So this one would be alpha VB2. And then, or VA2, I can replace with the same value because they are same. So similarly, I can write down VC2 is equal to VC2 is making minus of 120 degree. That means it will be alpha square VA2, right? So we have found three quantity, and the other quantity, zero sequence, will be the same as VA naught will be equal to VV naught will be equal to VC naught, and there will be no angle involved with this one. So all the quantity are of the same angle. So I can write down VA naught is equal to VA naught 0 and VV naught equal to VA naught 0 and VC naught is equal to VA naught 0 is the same. Now, we have mentioned that if I add these three sequence, I will find out the balanced system. That means if I want to find out the line A voltage of my faulty unbalanced system, this is, I have not used any subscript. That means this is the original system that has been decomposed. Then I have to multiply it with, so this will be equal. So this will be equal. And then I have to multiply it with my zero sequence. And then I will have to multiply with positive sequence.
Yeah.
And I have to multiply it with the negative sequence, A2. Okay?
Yeah.
Because all three components. Now, if I want to find out BB, then I have to multiply with A naught. Is actually, I can write down this is B naught plus VB1 plus VC1. Now, if I replace all these vectors, so these are all vectors, but A naught, all the component we have considered in the reference direction, so that's why I have not considered the angle. But here I will have the angle. So B naught is in the direction of the reference, so this is B naught, I can write down A naught. But V1, if you consider VB1, that is the positive sequence component. If you go here, find out the positive sequence component, then you have to multiply with A square. Okay, so this is 1. Okay. I don't know whether I have it. So this one is A1. No. Okay, where is that one? So this one here, right? So this is A1. V1 is multiplied with A square and the V1. So I have to replace here my original. It will be alpha square and then VA1. And now if you go to C2, this is actually C2 and VC2 is equal to
This figure squared. Yeah.
minus 120. Or it should be that I have written. So this is the B phase, right? So this is V0, I have to add. Then this is V1 and this should be V2. That's what I have made wrong here. Okay. So all the symmetrical component I have to add. So whenever I have added A, so A0 I have added, A1 I have added, and A2 I have added. Now, whenever I am considering V, so it would be zero sequence, positive sequence, and negative sequence of that phase. So if you consider that one, that this is my BB, and that BB should be V2, and that would be alpha. So I have to multiply here plus alpha VB1, so VA2. Okay. So I have converted to the equivalent because this VB2, this symmetrical component has the same magnitude. That's why I can replace VB2 with VB1, but we have to consider this angle. So alpha is indicating the angle. Similarly, I can write down VC, vector VC would be equal to VA naught plus it will be just opposite. This one will be alpha VA1 plus alpha square VA2. Okay. So C will be this one and B will be this one. Okay, so this is how we have to find out the phase. So I have to consider each finding out A phase, I have to consider three components of that A phase. What are the three components? Zero sequence component, A naught, then positive sequence component, A1, and the negative sequence component, A2. Now, BB is similarly the zero sequence component, this one. So let us just mark here. This is the zero sequence component, positive sequence component, and the negative sequence component. All are vector. So I'm just ignoring this one that we have already identified. This is AC, this will be vector. Now, whenever is vector, I need to consider the angle and the magnitude. So this one is the magnitude and the angle is 0 degrees. So I have not written anything. But this one will be, the magnitude will be the same as the positive sequence, A phase, but it has to be rotated by 120 degree. The 120 degree twice. That means positively 120 degree, A square. It has to each, A alpha has to indicate one rotation, the displacement of 120 degree. A2 is the same. So V2 is replaced with A2, but with A2, it has to be shifted by 120 degree. Then I will find out B2. So this is a negative sequence component. So that's why we'll find out with one shift. Similarly, I can find out with the positive sequence, negative sequence, zero sequence, positive sequence, and the negative sequence. Okay. And if you do this analysis, so this is how you can find out the fault unbalanced voltage. Now you might need to find out the balanced component. From the faulty component, unsymmetrical component, you need to find out. So if you do this analysis, then you will find out your zero sequence component. So your zero sequence component, I want to find out A0. What is A0? So that will be given by 1/3 of VA plus VB plus VC. I am not going to derive this one, just this will be, we need to know that this is, we can, so we have find out the unbalanced system. So if I know the symmetrical component, that means on the right hand side, I have all the symmetrical component, right? So I have 0, 1, 2, that is the symmetrical component. Symmetrical component. So if I know the symmetrical component, I can find out the unbalanced component. So unbalanced component, that means original component, actual component. I can find out if I know this unsymmetrical component. Now, most of the time, I will know for the faulty condition, faulty system, I will know these original or actual value. Actual value will be known to me. Then I need to find out the symmetrical component to analyze my circuit. So in that case, I need to find out the others. So from these three equations, we can do mathematical operation and find out the relation. But I am not interested to derive that one. But we can find out this one, that A0 and A1 can be found with this formula, 1/3 VA0. Sorry, this one would be the phasor. So this will be VA plus VB plus VC. So this one would be, angle should be considered. So this one should be considered. So this one will be alpha and plus alpha square. And VA2 would be equal to 1/3. Then it would be VA plus alpha square VB plus alpha VC. So this is the actual value. From the actual value, we can find out the faulty, the symmetrical component. So similarly, this is, I have written only one phase symmetrical component for the phase A. That means I can write down the symmetrical component for phase B and phase C in the similar way. And I don't actually need to do the calculation because they are all the same magnitude with the phase. Okay.
Yes.
So we don't need to separately calculate this one. All right.
You can see the terms, it's just going to be the same. Just terms are just swapped around like VA2. It's it's the same terms are in there. It's just swapped.
Okay, any question up to this? So what we have done, we try to understand a tool that will enable us to analyze a faulty system. And we take help of the knowledge of the analysis of a balanced system. So if we understand the analysis of a balanced system, and if we know that I can decompose, I can represent any unbalanced system with three balanced systems and separately find out the balanced quantity of those three systems, then I can find out the unbalanced quantity or actual quantity by doing the vector addition of the the valence 3 valence system. Okay, so that's what we have understood. We try to explain and try to give you an idea. Okay, any question up to this?
Yeah, just without the calculations, just purely looking at the vector diagram, so you can see that. So you can see, like you had when you drew the fault on that government system. So you can see, these two phases are going to drop. The phase is going to go shooting up.
Yeah.
I mean, without like, so you're stepping out ahead, you obviously calculate actual values, and you want to see principally, but just having that principal knowledge to say, this is this type of fault. I know this fault is going to shoot up.
Yeah.
I know the other fault is going to drop down. There's going to be a massive fault on that one, and probably nothing on the other.
So if you are experienced, if you are working in the system for a long time, you might be able to predict that, okay, this has happened, and you measure some of the quantities, then you can predict what has happened. But you might not know the actually how you have done it. But this knowledge will give you a tool that how you have come up with that idea.
Oh, exactly. Yeah. Yes. Exactly. Yeah. If you need to go into specifics and get the actual values and so forth.
Yeah.